Hello, and welcome back to Algebra 2, Lesson 1.6. Today, as you guys may know, we are going to cover Section 1.6 of the textbook, which is Introduction to Solving Equations. And today we're going to follow the textbook very strictly, so it's going to be a lot of lecture material, textbook material, a lot of memorizing and learning, and not too much problem solving. We're going to continue with another video about section 1.6 next week. So look forward to that. There we will do most of the problem solving, but today we will have to learn the basics to be able to solve the problems next week. So first up, we have what is an equation? So an equation is a statement that two expressions are equal. An equation usually contains one or more variables. A variable is a symbol that represents many different numbers in a set of numbers. For example, like this example given by the textbook, equation in one variable w, 12w equals 10. So as we can see, 12w equals 10. There is an equal symbol there. 12w is equal to 10. Two expressions are equal, which means that it is an equation, and the variable here is w. So w, we can input 1 or 2 or 3 or so on. Next, we have equation in two variables, x and y. This might be quite familiar with you guys because although it is in a different format right now, if we change this to x plus 3y equals 12, it can be a linear equation. So if we move the 2x to the other side, divide by 3, then we will get a linear equation that we graphed in the previous videos. So as you can see again, 2x plus 3y, that is equal to 12. So expressions are equal to each other, and there is the presence of a variable, or two variables in this case, x and y. Next, any value of a variable that makes an equation true is called a solution of the equation. For example, 12w equals 10 is an equation in one variable, w, because 5 over 6 satisfies the equation 5 over 6 is a solution. So looking at the first example that the textbook gave us, 12w equals 10. So what times 12 equals 10? So as you guys know, we can do 10 divided by 12 to get w, and 10 divided by 12 can be simplified to 5 over 6, which would be the solution, or what y is to make this equation true, to make this 10 equals 10. For example, if we input 1 for w, it would be 12 equals 10, which is not true. 12 does not equal 10, so that would not be a solution. But 5 over 6 would be a solution because it makes the equation true. 10 equals 10. Next, we have a lot of properties of equalities that you will have to memorize. More than memorizing though, these should come naturally to you as you use them more often. And if you know one of them, they usually lead to another. For example, like adding something and subtracting something. For example, you can add -2, or you can phrase that in a way where you say something minus 2, subtraction, but it can also be addition when you add -2. So sort of like that, you can sort of memorize one or a couple, and then the others will hopefully come naturally to you. If it doesn't, memorizing is the safest way to go because this should be ingrained into your mind. So first we have reflexive property, and all of these properties are for real numbers A, B, and C. This does not apply to non-real numbers or imaginary numbers, which you will learn later. So first, reflexive property, A equals A. So 2 equals 2, 5 equals 5. This is sort of a given. So basically this, you don't really have to memorize. You should already know this. We know already that 4 equals 4. 4 does not equal 3. 4 equals 4. Next, we have the symmetric property. If A equals B, then B equals A. So if 4 equals 4, then 4 equals 4. That is a bad example because I'm using the reflexive property again. But for example, if a problem says that A equals 2 and B also equals 2, then because A equals B, 2 equals 2, then B must also equal A. So because you're swapping the position left and right of the equal signs, when they're the same number, that does not change what they are. So like if you say x equals 2, that isn't different from 2 equals x. They're still the same thing. X still equals 2, and 2 still equals x. So that's basically what the symmetric property is. Next, we have the transitive property. So if A equals B and B equals C, then A equals C. So basically what this means is a problem says that A equals 2 and B equals 2, okay? So we know that 2 equals 2, A equals B. And then apparently it says that C is equal to B. That means that we know that C is also 2. Then if A equals B and B equals C, then A and C both equal B, which means that A and C are also equal to each other. So 2 equals 2. So A and B, 2 equals 2, and B and C, 2 equals 2, and A and C, 2 equals 2. They're all 2 equals 2. They're all the same. So A equals C for the transitive property. Next, we have the addition property. If A equals B, then A plus C equals B plus C. So again, I'm going to use the 2 example once again. A equals 2, B equals 2. So 2 equals 2. We know that already. Okay. Then 2 plus, let's say C is 3. 2 plus 3 equals 2 plus 3. Is that true? Yes. 2 plus 3 is 5. 2 plus 3 is 5. 5 equals 5. If you add the same amount to each side, then the equation would still be true. That goes the same for the subtraction property, as I said earlier. 2 equals 2, 2 minus 3 equals 2 minus 3. It would still be -1 equals -1. The equation would still be true if you subtract the same amount from each side of that equation sign. That goes the same for multiplication and division as well. If A equals B, then AC equals BC. 2 times 3 equals 2 times 3. 6 equals 6. Division property, if A equals B, then A over C equals B over C. 2 over 3 equals 2 over 3. It doesn't change the equation whatsoever, or it does change like what it looks like, but ultimately like the result, whether it's true or false, that will always be the same. They're always true if you use the properties of equality. That's why it's called equality. Next, we have the substitution property. So if A equals B, you may replace A with B in any true statement containing A, and the resulting statement will still be true. So what many students have a hard time with is this right here, the substitution property. It's because many people get the substitution property confused with the transitive property right here. If A equals B, B equals C, then A equals C. But that's not what's happening right here. So A equals B, and when you're replacing it, when you're using the substitution property, you're literally putting in B for A. So basically, if we're using this right here, the point I'm pointing at with the mouse, B equals C, but we know that A equals B, right? So we put A in for B, so it's A equals C, not the fact that A equals B, B equals C, so therefore, because they're equal to the same thing, they should also be equal to the same thing. So we're not using that logic here, but for example, if we use this equation right here, A plus C equals B plus C, what we can do with the substitution property is because we know that A equals B, I can put in B for A because A equals B. So B plus C should also equal A plus C. So I input B for A. So it's B plus C equals B plus C. So that's what's happening here. Transitive property, they both equal the same thing. Therefore, the two separate things must also equal each other. It is a different concept. You should not get this confused. If you're confused with this, come find the peer tutoring club members during lunch, ask your teacher, or search up online. There's a lot of resources regarding this, but yes, please be cautious so that you do not confuse these two. Next, in an expression such as 5 plus 3x minus x minus 1, The parts that are added or subtracted are called terms. The terms 3x and x are called like terms because they contain the same form of the variable x. The constant terms 5 and 1 are also like terms. An expression is simplified when all the like terms have been combined and all the parentheses have been removed. So basically, this should be a review thing. Everything so far should actually be a review from Algebra 1, maybe even pre-algebra, probably pre-algebra for like terms, because we know that we can't add x plus y. We can't add those two. We can't add 3x plus 4y. We can't say 7xy because no, that's a totally different concept because x and y aren't the same variable. Therefore, they cannot be added together. Only x's and x's can be added together and y's can be added together. So hopefully this is a review. If not, you can go ahead and look at the pre-algebra videos on the website or ask your teacher for help, or you can come visit the peer tutoring club members. But because this is a review, I'm going to cover it very lightly and move on. So 5 plus 3x minus x minus 1. So what we can do is 3x minus x, like terms, so 2x, and then 5 minus 1 are like terms, they don't have any variables. 5 minus 1 is 4, so 2x plus 4 is the simplified version, and you cannot add 2x and 4 together any further. This is as far as you can go. Okay, next. So what we're going to do with this is the last slide. I know we've already reached like 11 minutes and you guys might be getting tired of watching a video, but hold on just a couple more minutes. Let's get through this and then you can take a break and then maybe move on to the next video. So basically what we're going to do here is, although it looks really complicated, I practically solved the equations for you. 2x plus 5 equals 7x minus 2 equals, and the solution for it is x equals 7 or 5. I solved it for you. So this is basically just the solving process, and what we're going to do together is figure out what properties of equality I used. And then in the next video, you're going to try to solve these on your own using the properties of equality without me telling you. And then I'm going to tell you afterwards what properties of equalities should have been used. So here, let's see. So what did I do here? I subtracted 7x from both sides to get to this step, from this step to this step. So what is that? Subtracting from both sides. Subtraction property of equality. Yes. So 2x minus 7x plus 5 equals negative 2. And then what did I do? I simplified it, right? 2x minus 7x plus 5 equals negative 2 became negative 5x plus 5 equals negative 2. That means that I subtracted this right here. I did this calculation, 2x minus 7x. So what is that? That is just this, just calculating and simplifying the like terms. This isn't a property of equality. So we simplify that. Next, what did I do? I subtracted 5 from both sides. So again, subtraction property of equality, simplified it again using like terms. Then what did I do? I divided by negative 5 on both sides to get negative 7 over negative 5 equals x. That is the division property of equality. I divided by negative 5 on both sides. And then next, I just simplified this fraction right here. Negatives cancel out, x equals 7 over 5. Okay, yeah, that was the more complicated one. I put the easier one on the bottom. The second one, for some reason, maybe just to give you guys a little break before you log off this video. But let's get into this equation. 3x plus 7 equals 2. And then what did I do? I did 7 from both sides. 3x equals 2 minus 7. Subtraction property of equality. And then what did I do here? Like terms. 3x equals negative 5. 2 minus 7 equals negative 5. And then what did I do? Divided by 3 on both sides to get x equals negative 5 over 3. Division property of equality. So great job, guys. This is it for today, but next week, another video is going to go up about section 1.6 extended. We're going to solve more problems there, explore some of the concepts that we have learned but haven't gotten to use in the problems yet. For example, the substitution property, transitive property, reflexive property. So that is what we're going to do in the next video, and hopefully you'll watch the next video. Hopefully this video was informative, and thank you for watching this video, and see you next week. Bye.